All right, welcome to lesson 40. We are going to be multiplying and dividing rational expressions. So just so you know, the PowerPoint that I'm using, it's actually the second half of one PowerPoint that's for lesson 39 and 40. So the slide right before this is what we had done before in lesson 39. Anyway, there you go. Now I'm going back. There. Okay, so here's where we are, starting in the middle of that same PowerPoint. Now we're moving on to the next lesson, which is lesson 40 on multiplying and dividing rational expressions. So remember, a rational expression is basically a fraction. Rational refers to ratio, which is another word for fraction. So when we multiply fractions, we multiply across and we reduce if possible. And that is the same whether you're multiplying something like 2/5 times 1/3 or multiplying more complicated fractions or rational expressions as we have in these examples. So we'll start with two examples of multiplying, then we'll see two examples of dividing, and then a little bit later on, we will switch over and look at some of the homework examples. All right, so again, to multiply, you're going to factor completely, multiply across, and reduce if possible. So this is a new step, right? Factoring completely when we multiply fractions. That doesn't quite come into play until you have something like number 2 coming up, where you have these expressions with plus and minus signs, where there's more than one term in each part of the fraction. For number 1, each of these expressions is called a monomial, mono meaning one, one single term. So each numerator and each denominator is just one term. We will be able to just kind of skip over the factor step and just multiply across, reduce if possible. The one change I will make there is reduce if possible, do that first, and then multiply across. So here's what I mean by reducing if possible. Look for any common factors in the numerator and denominator, whether that's in the same fraction or kind of diagonal from each other in different fractions. So in this case, the first example that jumps out to me here is this 2z in the first denominator and then 2z in the second numerator. So the full problem is 15x to the third y squared over 2z times 2z over 5xy to the third. So this 2z in the numerator in the second fraction can actually cancel out with the 2z in the denominator of the first fraction, because anything divided by itself is just equal to 1. So I'm just going to go ahead and cross those out. I'm going to write a 1 in their place just in case. If we end up crossing everything out, we need to know that there's a 1 in the numerator or a 1 in the denominator. So let's look at the other terms that we have. We have a 15x to the third y squared, and then we have 5x y to the third in the denominator. We can actually do some reducing here as well. Now, those terms are not exactly the same, but there are some common factors. Let's start with the 15 in the numerator and the 5 in the denominator. We can reduce by dividing both of those by 5. So 5 divided by 5 just becomes 1 down here in the denominator of the second fraction. And then 15 divided by 5, that becomes 3. So essentially we're reducing 15 divided by 5, and that becomes 3 over 1, or just 3 in the numerator. Now there is more reducing we can do with these variables and exponents. However, it's getting a little bit messy at this point, so I am going to rewrite the problem just to give a little more space and not make it so messy over here. So here's what we have left. We have 3x to the third y squared over 1 times 1 over 1xy to the third. I'm just going to write xy to the third for now. I don't really need that 1 next to those variables for now. All right, so I think we've taken care of all the numbers here, but let's now pay attention to the variables. So remember, there is a rule when you are dividing with exponents. What you can do is subtract exponents. So I'm going to do that for each of these variables. X to the third over x. So there's x to the third in the numerator of the first fraction, and then x in the denominator of the second fraction. We can cancel out one factor of x here. Essentially what we get to do is subtract the exponents. There's a 3 up here at the top, and then even though you can't see it, there's technically a 1 exponent on that x. So when we simplify that, what we're going to get is just x squared left over in the numerator. So x to the third divided by x to the 1 is equal to x squared. So that's really what we just did. All right, so let's do something similar for the y's. This one's a little bit trickier. We have y squared in the numerator over y to the third in the denominator. So we can subtract those exponents, but be careful, the bigger exponent is actually in the denominator. So if we subtract 3 minus 2, we do get 1, but that y to the 1 will actually stay down here in the denominator. In other words, y squared over y to the third. It's really 1 over y to the 1. Or if you were to subtract from the top to the bottom, 2 minus 3, that would be -1. So you'd have y to the -1, but still that does mean you'd end up with 1 over y to the 1 for your final answer there. Okay, so it got messy again. Let's put it all together. We're just about ready to write our final answer. So let's see what we have left and we'll put it all together. All right, so we have 3x squared times 1. So what I'm trying to do at this point when I'm finishing up the problem, I'm going to multiply straight across in my numerators and then do the same for my denominators. So I have 3x squared times 1. That's going to be 3x squared for the numerator over. Now in my denominators, I'm left with 1 times y to the 1. So that's just 1y to the 1 or just 1y. So here's our final answer. It's a fraction, 3x squared over y. And that's our final answer. All right, now you might be wondering, why did we reduce first? Why didn't we multiply across and then reduce? That would have been an option. So here's another way you can do that one. You could have actually gone straight across right away, just multiplied everything together. 15 times 2, that's 30, x to the third, y squared z over, and then in the denominator, 2 times 5 is 10, x, y to the third, z. And then you can simplify in a different way. 30 over 10, that becomes 3. X to the third over x becomes x squared. Y squared over y to the third, you're left with y to the 1 in the denominator, and then the z's cancel out. So that kind of seemed way faster. But here's the thing, we are going to need to factor completely and reduce if possible first for pretty much every other problem that we're going to see. So as we're looking ahead at number 2, we do not want to just multiply all this stuff together. So we have x to the third plus 8. We don't want to take that and multiply it by x plus 5 in the numerator and distribute, because then we're gonna have to factor. Again, it would be way too long. So we are actually not generally going to multiply first. We are going to start by factoring first. So starting with number 2, for the rest of the problems in this lesson right now, anything that has more than one term in the numerator or denominator, we're going to factor first and then cancel. Okay, so let's start with, we'll kind of go in order. Let's start with the numerator of our first fraction, x to the third plus 8. We can factor that using the sum of cubes formula. All right, so here's that formula. Write it over here. So a cubed plus b cubed. So the formula goes like this, a plus b, and then a squared minus ab plus b squared. This is from our special factoring section. We still need to know those formulas. Okay, so that's the sum of cubes. So I'll use that formula to factor x cubed plus 8 and start to rewrite that. I'm going to replace a with x, and I'll replace b with 2 because 2 to the third is equal to 8. And remember, my original expression was x to the third plus 8 for that numerator. So a plus b, that'll become x plus 2 in parentheses. And then my next factor looks like, instead of a squared, it's x squared minus, instead of a, b, I'm multiplying x times 2. So that's 2x plus, and then instead of b squared, I'm doing 2 squared, which is 4. All right, so that's all just for that first numerator, x cubed plus 8. We use the sum of cubes formula to factor it into x plus 2, x squared minus 2x plus 4. All right, so we can kind of go in any order here. I'll stick with the first fraction first, and I'll just keep factoring. And then after we're done factoring each part, we will start canceling out common factors. So let's move on to x squared minus x minus 6. This is a trinomial. I can basically use FOIL to break it down and factor it into 2 binomials. The first term is x squared, so that means my first terms will be x and x, because x times x is x squared. My last term is minus 6, so I need factors of negative 6. And that middle term, that minus x, remember that's really a minus 1x. So I need factors of negative 6 that add up to negative 1. That's going to be minus 3 and plus 2, because negative 3 times 2 is negative 6, and negative 3 plus 2 is that middle term, negative 1. Okay, so you might notice we already have a pair of common factors that we could cancel. That x plus 2 in the numerator can cancel with the x plus 2 in the denominator. So feel free to cancel those out right now, or if you want to save all the canceling for later, that's fine too. All right, let's move on to the second fraction. The numerator, x plus 5, you really can't do anything to it, so we just get to copy it. X plus 5 can't be factored, it's just already simplified. So it's just a simple binomial factor. So I'm just rewriting it, x plus 5 in parentheses. And believe it or not, this trinomial down here, 3 terms, x squared minus 2x plus 4, that also cannot be factored. It kind of feels like it could, so you might try to factor it. It's a trinomial, it starts with x squared. You start thinking, okay, I need factors of 4 for my last 2 numbers, and they need to add up to negative 2. Okay, 1 and 4, no, that's not gonna work. 2 and 2. Yeah, there's no combination that's gonna work here where my factors of 4 would add up to negative 2. So this is actually, believe it or not, prime. It can't be factored. That doesn't mean our whole problem is prime. It just means this one expression is prime. So that's a little bit surprising to have a trinomial, 3 terms that can't be factored. So we're going to just copy that down as well. All right, so let's take a look now to see what we can cancel out. All right, so we already mentioned we had this pair of common factors in the first fraction, x plus 2 in the numerator over x plus 2 in the denominator. We can cancel those out. And now we have another pair of factors we can cancel, kind of diagonal from each other. That trinomial, the 3 terms, x squared minus 2x plus 4 in the numerator of the first fraction, that can cancel out with x squared minus 2x plus 4 in the denominator of the second fraction. So that whole parentheses, that's one single factor in the numerator that cancels out with that same factor in the denominator. So I think we've finished crossing everything out that we can. Maybe I should be writing the number 1 every time I do that. Sometimes that will be necessary, not really in this case. And now we multiply across and we're about ready for our final answer. So 1 times x plus 5 is just x plus 5 in the numerator over x minus 3 times 1, that's just x minus 3. And we're done. So here's our final answer, x plus 5 over x minus 3. Feel free to leave each expression in parentheses, or you don't necessarily need to in this problem. Okay, so I hope that you're seeing some similarities between these two problems and what we had done in our last lesson. It's still a lot of factoring and canceling. It's just that now instead of one fraction, you have two fractions. So you can cancel within the same fraction, but you can also kind of cancel in that diagonal direction. All right, we're going to keep going now. Let's take a look at some dividing problems. So here's a reminder. This slide says divide rational expressions. And then in quotes, it says keep, change, flip. So that's the phrase that I've used when teaching about fractions. You keep the first fraction the same, change division to multiplication, and then you flip the second fraction. That means you're going to be multiplying by the reciprocal. Okay. So then after you do that, we're going to factor, cancel, multiply across. So we'll kind of do all of those things, maybe kind of all at the same time. Let's see. So I'm just going to go ahead and start factoring my first fraction. Then when we move to the second fraction, we'll remember to change division to multiplication. And then as we're rewriting that second fraction, we're going to flip it, but then we'll kind of factor as we go as well. Let's start with the first fraction. 2v squared minus 10v minus 28. Let's see if we can factor that. It starts with a 2. I'd like to see if there's a common factor of 2 we can start with, and as it turns out, there is. So I'll start by factoring out a 2. That leaves us with v squared minus 5v minus 14 because we're dividing each of those numbers by 2. And then that trinomial, v squared minus 5v minus 14, that can be factored even more. So we're factoring completely here. So I'm writing it out as two binomials. V times v is v squared. I need factors of negative 14 that add up to negative 5. That's going to be minus 7 and plus 2 because those numbers multiply to negative 14 while adding up to negative 5. So all of that, that's a factoring problem in itself, right? All of that was just that first numerator, that first trinomial in our first fraction. Let's move to the denominator, 3v plus 15. There's only two terms. There's a common factor of 3. We can take out the 3, and then in parentheses, we're writing v plus 5. Okay, so I think we're all good with that first fraction. There doesn't appear to be any common factors that we can cancel out yet. So we'll just keep going. Keep in mind we're doing keep, change, flip because this is a dividing problem. So this division sign is about to change to multiplication. And when we rewrite our second fraction, we're going to flip it. That means we're going to take the reciprocal. So this v plus 5 that was in the denominator, let's rewrite that v plus 5 in the numerator. And before we fill in the denominator down here, let's see if we can work on factoring. So 2v squared minus 98 is what we have. Let's take out a 2 first. There's a common factor of 2. Okay, so 2v squared minus 98, we factor out a 2, and we're left with v squared minus 49 in parentheses. This is a difference of squares. We can use that a plus b, a minus b factoring pattern or formula. So that becomes v plus 7, v minus 7, because 7 squared is 49, and v squared is v squared. All right, so let's write all of that out in our denominator. So we still have that 2, and then in parentheses, v plus 7, close the parentheses, and then v minus 7 as our last factor. Okay, so we're taking a look at what we have. We've rewritten the problem. Each part has been completely factored. We factored out a 2 in the numerator over here, 2, v minus 7, v plus 2, over 3, v plus 5. Division changed to multiplication. Then we flipped the second fraction. Keep, change, flip, right? The v plus 5 moved from the denominator to the numerator. And then we ended with 2v squared minus 98. We took out a 2. And then the v squared minus 49 got broken down more into v plus 7, v minus 7. Okay, now comes the good part when we get to cancel. So now let's take a look and see if there's any common factors in the numerator and the denominator that we can cancel. Now, as it turns out, each of these fractions by itself cannot be simplified. There's nothing in common in a numerator and denominator of a single fraction. However, if we cancel kind of in that diagonal way, something in the numerator of the first fraction could cancel out with something in the denominator of the second, and vice versa. So let's start with this 2 that we factored out. 2 divided by 2 is just equal to 1. So those 2's will cancel out. I just crossed them both out. Let's see if we can spot any other common factors. Here's one, v minus 7 in the numerator, canceling out with v minus 7 in the denominator. All right, what else? This v plus 2, nope, I don't see any more of those. How about this 3 in the denominator? I don't see a 3 in the numerator. I'm going to leave that alone. It looks like the last thing we can cancel out is this v plus 5 in the denominator of the first fraction. Cancels out with the v plus 5 in the numerator of the second fraction. So at this point, lots of things have been canceled out. Now we need to carefully rewrite everything, rewrite what's left over that we haven't canceled out, and that will come together for our final answer. So in our numerators, the only thing we didn't cancel is this v plus 2. So that's in our numerator. I'm going to put it in parentheses just in case. You don't really need to, but a lot of times you will. We're going to need to keep something in parentheses in the denominator, because what we have left, we have this 3, and then we also have this factor v plus 7, and that will need to stay in parentheses. This is our final answer. Keep it factored. This is called factored form. Okay, so in other words, do not distribute the 3. Keep everything completely factored. Okay, so that was an example of dividing. Keep, change, flip. So we factored completely in every single part of each fraction. The division changed to multiplication. The second fraction flipped, and we multiplied across, multiplying by the reciprocal. It didn't really feel like multiplying, though. We were basically just factoring and canceling still. All right, we have one more to do in our PowerPoint here, and then we'll take a little pause and we'll take a look at some homework examples. Some of those are slightly harder than what we have here. All right, so here's number 4. It's another dividing problem. 2y plus 10 over 3y squared minus 9y divided by 4y plus 20 over y squared minus 9. So I'm noticing each part of this problem, it seems not as long. Each part is only a binomial, 2 terms, rather than 3. We don't have any trinomials here. So we'll just keep that in mind as we're factoring. Let's try to factor everything we can in the first fraction. 2y plus 10 has a GCF of 2, so we can factor out a 2, and we're left with 2 and then y plus 5. In the denominator, 3y squared minus 9y, there's a GCF there of 3y. And then if we divide each of these terms by 3y, we're left with y minus 3. Okay, I don't see any common factors there. I'm just going to rewrite that. So 2y plus 5 in the numerator over 3y, y minus 3. All right, let's move on to the second fraction. Okay, this division is going to change to multiplication. All right, so we're going to keep, change, and then flip. So we will be flipping that second fraction. So let's factor as we go. This 4y plus 20, we can take out a 4. We're left with y plus 5. It started out in the numerator, so we rewrite it in the denominator. So 4 and then y plus 5. The y squared minus 9, that's a difference of squares. That's the a squared minus b squared pattern. So a plus b, a minus b, except this time it's going to be y plus 3, y minus 3. And we're flipping that fraction, so that y squared minus 9 started out in the denominator, and now it's in the numerator. All right, so here's what we have. 2y plus 5 over 3y, y minus 3. times y plus 3, y minus 3 in the numerator over 4, y plus 5 in the denominator. And now we cancel. So let's look for common factors. Once again, there's no common factors within each individual fraction, but we can cancel things diagonally. Let's start with the y plus 5s canceling out, and then these y minus 3s canceling out. Now be careful, this 3y and this y plus 3 might look kind of similar because they both have y's and they both have 3's, but they are definitely not the same. So do not cancel those. Y plus 3 has to stay where it is. The only way you would cancel out y plus 3 is if you had another y plus 3 in parentheses, which we do not have. Now what we can cancel out here that's easy to miss because we're so focused on the parentheses is these outside numbers, these numbers that we factored out as GCFs, this 2 and 4. So because we factor them out, we can treat them as separate factors and reduce. 2 over 4, we can divide them both by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And now let's multiply across with what we have left. So this 1 gets multiplied by y plus 3. So that's just 1 y plus 3, which means I don't even need to write the 1 in the final answer. In the denominator, this 3y gets multiplied times 2. So we do want to multiply those together because they're both single terms, they're both monomials. So we will multiply those together. 3y times 2 is 6y. So our final answer is y plus 3 over 6y. And in case you're wondering if you can do anything with the 3 and the 6, you can't. Because as I said before, this y plus 3, it's all one factor. The only way you could cancel it is if there was another factor of y plus 3. All right, good. So I think we've made it to the end of our PowerPoint notes. So you've gotten an overview. Some of the problems on the homework are a bit harder. There's at least one near the end where you have to multiply and also divide. It's a little bit longer. So I want to show you that one. And there might be a couple others that are just slightly trickier. So I'm going to pause and then switch my screen over to the homework and we'll take a look at a few more examples. So feel free to take a break, try some of the homework on your own if you prefer, or stick around and we'll see some more examples together. All right, so we're looking at homework number 40. We're going to start with number 1. You've seen problems like this before, but it's a multi-part question. It's meant to break it down and make it easier for you, but that might not be the result. So I'm going to show you the steps just to make sure you understand what's being asked each time. So divide and simplify. You can see in the bottom left, 6 parts remaining. So there's several parts here. X squared plus 8x plus 15 over 4x minus 20 divided by x squared minus 2x minus 15 over x minus 5. Okay, so the first question says, when dividing rational expressions, what is the first step? So let's read the choices. To divide by a rational expression, first multiply by its reciprocal. Yeah, I think that sounds right, actually. But I'm going to read the other choices just to be sure. Choice B says, to divide by a rational expression, first divide the corresponding denominators. Nope. Choice C, first rewrite each expression with a common denominator. No, that's for adding and subtracting, which we're not doing right now. To divide by a rational expression, first divide the corresponding numerators. Nope, so it's choice A for me. Yours might be different. Multiply by the reciprocal is that key phrase. Keep, change, flip, in other words. All right, so now we're going to rewrite, it says rewrite the division expression as the multiplication of the reciprocal. So it's having us take that second fraction and flip it. It looks like they rewrote it as the division as multiplication. The x squared minus 2x minus 15 is now in the denominator. So our original denominator, x minus 5, is now in the numerator. And that's what we get to type in, x minus 5. Okay, what's the next best step? I'm thinking we should factor, so let's see if that's one of our choices. Multiply the numerators and denominators and then factor wherever possible. Yeah, probably that one. Okay, let's see the other choices. Divide the numerator and denominator of each fraction by the LCD. No, nothing with LCD here. We're not doing that. That's for adding and subtracting. Choice C, multiply the numerator and denominator by the LCD. Nope. Multiply the denominator of the first fraction by the numerator of the second and no, I'm not even going to finish that sentence. Nope. So it's, once again, for me at least, it's choice A. Yours might be different. Multiply, then factor wherever possible. So this is multiplying across, factoring completely. That's basically what that means. All right, now we get to actually factor. Okay, so multiply the numerators and denominators, then factor the numerator and denominator. So okay, this is different. They're actually putting it all together in one giant fraction and then factoring. That is actually a little different from how I showed you. I had us factor first and then cancel. So it all works out to the same thing. Let's start with this first trinomial, x squared plus 8x plus 15. We need factors of 15 that add up to 8. That would be 5 and 3. So x plus 5 and then x plus 3 for my first little fill in the blank. And we still have this x minus 5 here as well. Meanwhile, down in the denominator, 4x minus 20, there's a GCF of 4. That's been taken out. 4 and then x minus 5. X squared minus 2x minus 15. We need factors of negative 15 that add up to negative 2. That would be minus 5. And positive 3. All right, and now we get to cancel, I hope. Oh, what's the next best step? Choice A, the fraction is fully simplified, so the division is complete. No. Choice B, multiply the numerator and denominator by the expression in the denominator. And okay, no. Choice C, rewrite the numerator and denominator in exponential form. Definitely not. Choice D, remove a factor of 1 and simplify. Yeah, cancel out common factors. So that's this one, remove a factor of 1. That means when we cross out common factors, we're doing that because anything divided by itself is equal to 1. So that's what they're doing here. So the x plus 3s, those equal to 1. The x minus 5s, those are equal to 1. So now we're going to write our final answer. The x plus 5 is left over in the numerator here. 4, and then x minus 5 is left in the denominator. And I think we're done at that point. Yeah, there you go. All right, so nice long question to get us started here with number 1. So I have another one I want to do with you that is harder. And I think I'm going to take us to number 11. Yeah, all right. Number 11 and then number 20 is another good one. Okay, here's number 11, multiply and simplify. So it's w squared minus x squared over w cubed minus x cubed times w squared plus wx plus x squared over w squared plus 2wx plus x squared. Okay, so I think we've seen something similar to this in our last lesson, maybe, but all right, here's what we need to know. We're going to need the perfect squares formula, difference of squares, as well as difference of cubes. So let's factor each expression one at a time, if possible. All right, w squared minus x squared. We can do the difference of squares. That becomes w plus x, w minus x. That's for that first numerator. Now in the denominator, we're going to use the difference of cubes formula. I'll just remind you of that. A cubed minus b cubed equals a minus b, and then a squared plus ab plus b squared. So that's the formula. We'll basically just replace a with w and replace b with x. So it becomes w minus x, and then w squared plus wx plus x squared. All right, so that's the first fraction factored. If you want, you can go ahead and cancel something out right now. I see a common factor, the w minus x over w minus x. Those will cancel out. All right, let's move on to the second fraction. Now keep in mind this trinomial, 3 terms down here that came from the difference of cubes formula, that thing cannot be broken down further. So the trinomial part of the perfect cube formulas, those cannot be factored further. So leave it alone. And please notice that that is the exact same thing as what is in the numerator of the second fraction. So I'm just going to copy that down. W squared plus wx plus x squared as a trinomial. Those are going to cancel. So the numerator of that second fraction, we can't break it down. Even if we tried, it's prime, it's not factorable. And thankfully we get to just cancel it out. Which brings us to the very last part here. You might be hoping this one is also prime, but it's not prime. You can break it down. So this one is w squared plus 2wx plus x squared. This one, this is actually called a perfect square trinomial. So if I try to factor it, w squared is my first term. So I can break it up into 2 binomials. They can each start with a w, because w times w is w squared. And I can put some plus signs here. Everything's positive. The last term, x squared, my last 2 terms need to multiply to x squared. Okay, and then this middle term, notice that my last 2 numbers, 1x and 1x, if I add those together, they add up to that middle term. In other words, let's check it with FOIL, just so you can see why this works. So w plus x, w plus x. I put a 1 in there. That's not really necessary. That might be confusing you. So I'll just take that out for now. So w plus x, w plus x. Let's distribute. Here's what we get when we distribute. W squared plus wx plus xw, except I'm going to write that as wx as well. Same thing, plus x squared. If we add those together, we get w squared plus, and then look at this, 1wx plus another wx is 2wx, and then plus x squared. Yeah, so that's where that 2 comes from. Anyway, there's something about the w's and the x's. I thought that one looked a little harder. Maybe you don't feel the same. But that's how that one is factorable, whereas the one above would not be. All right, so are we done? Let's see. I've crossed out a bunch of things. I crossed out the common factors of w minus x. We crossed out those trinomials. And we get to cross out one more thing. W plus x in the numerator with one of the w plus x factors in the denominator. And now, if you look carefully in this problem, everything got crossed out in the numerator. So that might feel like there's nothing there, but there's not nothing. Remember, each time we cancel out common factors, it's because anything divided by itself is equal to 1. So really, our numerator is just 1 times 1 times 1, which is 1. Meanwhile, in the denominator, 1 times 1 times 1 times w plus x, that leaves us with w plus x in the denominator. And that is our final answer. So it's 1 over w plus x. After all that work, sometimes students are confused and just think, oh, the only thing that's left is w plus x, so I'll just type in w plus x, and that would be incorrect. It's 1 over w plus x. Okay, I'm going to just type it wrong first, just to see if there's anything helpful that we get to see. Yeah, so I'm getting the answer wrong. It's just giving us some reminders here. So here's what the answer actually is. It's a fraction, 1 over w plus x. Okay. Good. All right. Now, let's do another hard one. I'm going to skip to the very last question, which is number 20. Yeah, see, I told you. Okay. So perform the indicated operations and simplify the following expression. So it's kind of 2 problems almost. There's 3 fractions. The first 2 are being multiplied and then there's a division for the last one. If you can do the other problems we've done, you can do this one as well. It's just a little longer, but still it's the same skills we've been practicing. So one thing at a time. So y squared minus 6y over y squared plus 4y minus 12. I'm going to work on that first. Y squared minus 6y, I can take out a y. I'm left with y minus 6. All right, so we're doing this one. The trinomial down there, y squared plus 4y minus 12. Breaking it up into two binomials, I need factors of negative 12 that add up to 4. That would be plus 6 and minus 2. Okay, times. Let's move on to the next one. Times. Y minus 2 in the numerator. Just going to put some parentheses around that just to remind myself it's just one single factor. And then in the denominator, y squared plus 12y plus 36. Two binomials, everything positive. My last two numbers multiply to 36 and add up to 12. That's going to be plus 6 and plus 6. I know I could write y plus 6 squared, but I'm going to leave them separate for now. It's possible I might be able to cancel something out. We'll see. I like leaving them separate at this point. All right, now for our third fraction, remember this is a division sign here. So I'm going to rewrite it as multiplication, keep, change, flip. So I'm keeping everything else as it is, but changing that to multiplication and then flipping it. So the denominator of the original problem, y to the 4th, is now in the numerator, y to the 4th. And then what was in the numerator, y squared plus y minus 42, that we can now break down. We can factor that and put that in the denominator. So here we go. Y squared plus y minus 42. So two parentheses, the first two terms are both y, because y times y is y squared. I need factors of negative 42 that add up to 1. So in other words, numbers that have a difference of 1. It's going to be 7 and 6. Since that's positive 1, I need my bigger number to be positive, smaller number to be negative. So that's y plus 7, y minus 6. Okay, so feel free to just pause and make sure you got all that. None of that was new though. I mean, it's just a lot of factoring. You're just practicing factoring. All right, so now, just like the problems we've done before this, we get to multiply across and cancel anything out that we can. So cancel out common factors, removing factors of 1, in other words. So let's see if we can find any common factors. I'm starting with this y. I don't see any other y's that are just a single factor of y. Everything else is in parentheses down here. So I think this y is going to stay where it is. We'll just leave that there. How about this y minus 6 in parentheses in the numerator? I see another y minus 6 in the denominator. And yes, even though they kind of feel far away, these are all going to be sort of smushed together into one final answer. It's a strange way of saying it, but we're going to multiply everything together. It will all become part of the same fraction at the end. So what's important is this y minus 6 in the numerator will cancel with the y minus 6 in the denominator. So just cross those out. Feel free to write a 1 in their place. Okay, let's see, what else? I see this y plus 6 in the denominator. I see some other y plus 6s, but they're all in the denominator. I really want to cross things out here, but we have to keep all of those. The only way we could cross out a factor of y plus 6 in the denominator would be if there's 1 in the numerator to cancel it out. And we don't have that, so we're going to keep all of those. All those y plus 6s, we're going to be keeping those together. In fact, I think what we'll end up doing is writing y plus 6 in parentheses to the 3rd. I think that will become part of our final answer. All right, let's see. Can we cross anything else out? How about the y minus 2? Yes. Okay, we can cross those out. Y minus 2 in the denominator. and then y minus 2 in this numerator. Those will cancel out. We can write a 1 there if we want to. All right, and then we have this y to the 4th. I think what we're going to do is actually multiply that y to the 4th times this y. They're both in the numerators. When we multiply those, that will end up becoming y to the 5th in our numerator. Okay, now did I miss anything? Let's see. We have the y times y to the 4th. Everything else in the numerator got canceled out. So we have y to the 5th. That's going to be our numerator. Let's double check the denominator. Y to the 6th, y to the 6th, y to the 6th. That becomes y, or wow, sorry, not y to the 6th. I'm sorry, y plus 6, y plus 6, y plus 6. There's 3 of them, so we can write y plus 6 to the 3rd power. And then the last part that I hadn't written yet was this y plus 7. There's only one of them. Nothing will cancel it out, so we're going to keep it where it is in the denominator. And I think we have it. So our final answer is, as one single fraction, y to the 5th over y plus 6 to the 3rd times y plus 7. Okay, can I type that? Let's find out. Okay, so y to the 5th. Now, in terms of the y plus 6 to the 3rd, I think you can write them 3 times. I think that's okay. I mean, it gets long. But if you don't want to write it out 3 times, you would click on this exponent button and then put a power of 3, and then the y plus 7 in parentheses. Let's see if it'll accept it with it written separately. I think it should be fine. It's just longer. Okay. Oh, it doesn't like it. Interesting. Okay. That's good for me to know. Although your answer is equal to the correct answer, it is not in the correct form. Okay, so my mistake. Y plus 6, y plus 6, y plus 6. We got to use that exponent. All right. I didn't realize that. There we go. Let's see if that's better. There it is. All right. Well, now you know. Good. Okay. So I tried to show you some of the harder problems on this assignment. There are some near the beginning that are meant to be easier, but therefore might feel confusing. There is one that I'm thinking of here. Sorry, I know I'll find it. Okay, I guess it's not in the beginning, my mistake. Here, I guess it's this one, number 13. I don't know, there's something about seeing these x's. Number 13 says divide and simplify. 8x plus 32 over x. I mean, you just factor out that 8, so it's 8, and then x plus 4 over x. This is division, so you change it to times, flip the second fraction, and then there's nothing to factor there. So you just leave x as it is, and then x plus 4. The x plus 4's cancel out, the x's cancel out. You're left with 8 over 1, which is just 8. Okay, so maybe I was wrong, maybe that wasn't as tricky as I thought, but all right, good. So I'm going to resist doing this entire assignment. There is something else that caught my eye here. Yeah, I guess it's this part. So we'll end with number 12. It looks like there's 2 parts to this, and then we'll wrap this up. Okay, so number 12 does have some monomial expressions. We saw one like this in our notes near the beginning. There's no plus or minus signs. So it's 50x to the 10th over 2y to the 4th divided by 625x to the 3rd over 10y squared. So I'm going to rewrite that, keep change flip. So 50x to the 10th over 2y to the 4th times, and then we're going to flip this, 10y squared over 625x to the 3rd. Okay, so we can definitely simplify quite a bit here. There's a few different ways you could go with reducing. Oops. I think we're kind of used to doing it sort of diagonally, looking at the numerator of one fraction and then simplified with the denominator of the other. So we can start there. 50 and 625, they both can be divided by 25. Okay, let's see, 625. I don't trust myself to do it in my head right now. All right, and that's 5. Yeah, that's what I thought. Okay. Okay, 625 divided by 25 is 25. 50 divided by 25 is 2. And then we can subtract those exponents with the x's. 10 minus 3 would be 7. So 2 and then x to the 7th is left up here in the numerator times, and then down here, 25 is all that's left in the denominator. So we'll start there. And then let's take a look at the other expressions. 10y squared in the numerator, and then 2y to the 4th. Okay, so 10 and 2, we can divide both of those by 2. 2 divided by 2 is 1. 5 divided by 2 becomes 5. So that's 5 and 1. And then we can subtract those exponents of the y variables. Notice the bigger exponent is in the denominator, so we can subtract 4 minus 2, but we're left with that y to the 2, or y squared, in the denominator. All right, good. And now let's see, we can multiply across. It looks like we're almost done. I guess I can also reduce this 5 and 25 now that I take a look at the second fraction. 5 divided by 5 becomes 1. 25 divided by 5 becomes 5. Now I multiply across. 2x to the 7th times 1 is 2x to the 7th. 1y squared times 5, that would be 5y squared. And do one last check. Do 2 and 5 have any common factors that we missed? Do x and y have any common factors? No, so we're good. So our final answer, the simplified quotient, is 2x to the 7th over 5y squared. 2x to the 7th over 5y squared. All right. Oh, and I guess that's it. Okay, very good. So I'm going to wrap it up here. And the lesson that comes up after this, lesson 41, we will get into some adding and subtracting with rational expressions. So that's what we have left. Okay, thank you for hanging in there, and let me know if you have any questions.